All right. So, well,
Doc.
Yes, please.
Sir,
Yes.
it seems like last Monday we didn't finish with the session 10.
Really?
We didn't, yeah.
All right. So, guys, welcome to today's session. Yeah, so today we'll look at the IRR, what we call the internal rate of return, IRR. IRR, internal rate of return. Okay. Now, for the internal rate of return, this is that interest rate that takes our NPV to zero. What do I mean by an interest rate takes our NPV to zero? Now, you would agree with me that in computing our NPV, we use a certain interest rate, and that interest rate is what discounts the future values, okay, and brings it to the present term. And then whatever we bring to the present, we deduct it from the initial investment. So when we discount our inflows, okay, or the cash flows that we have, and the difference between the total inflows and then the initial investment or the initial capital outlay, and we have a ratio that is equal to zero, that interest rate at which we do that computation and arrive at that ratio of zero, we refer to that interest rate as our internal rate of return. In actual sense, that refers to a break-even point. You know that at break-even, the business isn't making profits, neither is it making losses, okay? So at break-even, whatever you invested turns out to be the same thing that you would gain. And so there is neither profit, there's neither loss. That is why the expression here says, you would find out that given our discounted inflows minus the initial capital outlay, we end up having zero. Okay. Now, it says that is taking time value of money into account. The IRR is the maximum rate of return that an investment is able to recover the initial capital rate of initial capital outlay. Most organizations have an established minimum returns that any investment must meet. This is usually termed as the minimum acceptable rate of return. For such organizations, it is only when the IRR is greater than or equal to MAR will the potential investment merit consideration. So in a more, let's say in a lesser complicated sense, compare two interest rates. Now, certain organizations may not necessarily place the value on what's it called, maybe the NPV or the annual worth or other things. They rather want to look at the percentage of change, or as in the interest rate. And so for such organizations, they have a certain threshold of interest that they would not tolerate. And so beyond that interest rate, they wouldn't be willing to accept that. So oftentimes, when we know that the interest rate, when our IRR refers to that interest rate that takes our NPV to zero, then if a business has a certain rate of return, which we call the minimum acceptable rate of return, then in any case, even if the IRR turns out to be the same or greater than the minimum acceptable rate of return, then that project obviously would be a viable one. Think about it. Let's say, I'm just giving an example. Suppose that we have a 10%, at 10% is our internal rate of return. So it means that per whatever cash flows that we experience, at an interest rate of 10%, our NPV will be equal to zero. So it means at 10%, we would break even. We are not going to make profits or losses. Now, if the company has an MARR, or which we call the minimum acceptable rate of return, as 12%, it means that in the eyes of the board, this this rate for our investment is a loss. It means it is lesser than even the minimum acceptable rate of return. It means that although we would be experiencing a break even at this point, the company feels that the least possible investment rate that we will be considering should be 12%. So think about it and say, if you were going to a bank and you're looking for a bank to invest, you can tell yourself that, well, I have this amount of money. And if I were to engage in any investment in any company, I won't put it in any investment that is less than, that is 7% or less. I would only consider interest rates that are higher than 7%. So this 7% becomes your minimum acceptable rate of return. Okay. So if you get any investment that is higher than 7% or the same as 7%, well, you would make a decision and say, okay, fine, this investment is worth undertaking. So we will take it. But anything less than 7% will be 6%, 6.5, 6.8, 6.99, so less than 7%. You wouldn't take it. Okay. So it is only when IRR is greater than or equal to MAR will the potential investment merit consideration. Okay. So thus the following rules apply when we're using the IRR. One, when IRR is greater than MARR, investment is profitable in the eyes of the board anyway. When IRR is equal to MARR, investments add no value to the investor, and so the investor is indifferent. Well, sometimes for the sake of the customers, you do not want to lose your customers, or for some greater good, so you may still consider it. But in the event where the internal rate of return is less than your minimum acceptable rate of return, then that project is not worthwhile, and that will not be a project the business should be investing in. Okay. Now, when comparing two or more projects, the first condition for any project to merit consideration is for it to have an IRR greater than or equal to MAR. For those projects meeting this criterion, select the project with the maximum IRR. So if you have two projects, okay, that would have different internal rates of return, we would compare each internal rate of return with the minimum acceptable rate of return for a starter. Now, if both of them are higher than the minimum acceptable rate of return, well, then we now compare the actual internal rate of returns for both projects, and then the project with the higher internal rate of return should be selected. So take an example. Let's say we have two projects, 1 and 2. This is their internal rate of return. One has a rate of return of 13.5, the other one has 14%. And then the minimum acceptable rate of return for the company is 12.5. Now, in this instance, we first compare this. Now, you see that the IRR for project 1 is greater than this. This is also greater. Now, the decision is, well, both of them have passed the test, the first test of comparing the IRR and the MAR. So both projects in the eyes of the company are viable, but which should we actually select? We would select this one because it has the higher IRR. That is what it's saying. Okay, so say suppose project 1 and 2 have IRR greater than MAR, and IRR 2 is also greater than this, then respectively, it means that they are mutually exclusive. If IRR 2 is greater than IRR 1, then select project 2. Okay, so that's just what we just put. All right, so does someone have a question? All right, so in calculating the IRR, we have a graphical approach that one first select. We are not going to really well with this, and actually for this IRR concept, I need you to just understand it. It's not, we are not going to really do so much of it new. So the graphical approach requires that you first select an interest rate I, okay, an arbitrary interest rate, or select an interest rate I1. So let's call the first interest rate we select as I1, and calculate its corresponding net present value. And so at interest rate I, or interest rate 1, given the cash flows, you will get a certain NPV. So we'll call it NPV1. Okay. So that will on the graph, we will call it at points I1 and interest and NPV1. Okay. So maybe you have at this point, okay, and then the NPV, suppose it's a positive NPV. Now note that we can have both positive and negative NPV. That's that you can make a loss and we can, so it depends. So suppose we have our NPV. So you can have the first stuff and then the first NPV. You draw your stuff, you put it out there, and then again, I2, which is associated with NPV2 for the point and I2 and that. So probably let's say this is a second NPV and this is the respective this thing. This is the first NPV and probably this is the, how do you call it, the first, this is the first I and then the first NPV, second I, second NPV. So we compare, we kind of like draw a line through them. The point where it touches the x-axis, okay, that point we refer to it as the I naught, which is our internal rate of return. Now, ideally, when you have a negative NPV and then a positive NPV, it even makes it easier. It's more clearer to have the where your IRR falls. However, in the instance where both of your NPVs are positive and you draw your graph, you just have to extrapolate, like extend it to touch the x-axis, and then the point where it touches the x-axis, that's interest rate. The point where it touches the x-axis would be the point where your IRR sits. Okay, so it says, so let's look at it algebraically, because sometimes on the graph, if you're actually using a graph, you would have to kind of like have, well, how do you call it? You have to draw your graph to scale to be actually have that accurate internal rate of return. So for the mathematical approach, let's still use the same concept of the equation of the line. Okay, bear in mind that this is there's an x-axis, this is a y-axis. Okay, it means that there will be y coordinates, x coordinates. Now, in this case, the y coordinates are the NPVs, the x coordinates are the interest rates. Okay, so NPV1 against interest rate 1, NPV2 against interest rate 2. So you can see this as y2, this will be like y1. Then this will be x1 and this will be x2. Okay, that's similar concept. Okay, because it's a straight line. So here the slope is in this regard, which says so we can have the y1 minus y2 or x. I think it should be x2 minus x, y2 minus y1, x2 minus x1. It says it can be observed that the slope of the line above, it can be observed that the slope of the line above the slope of the line is this. So we take the NPV1 minus NPV2 over the first interest rate minus second interest rate, or we can also have NPV1. So yes, so NPV1 minus 0 all divided by I1 minus the internal rate of return. And it's just saying we have, well, there are several coordinates. Okay, so the understanding is you can choose this and this as the x and y coordinate for the first. Then you can either choose this and that, or you can choose this and that. Either way, you still find the slope because it's still the same straight line. And we have said for a straight line, the slope is the same at every point. Okay, even here, the slope is the same as it is here and everything. So, all right. So when we seek to rearrange these expressions here, okay, so we are saying that even if you use this expression, okay, it is the same as using this expression. Okay, so then this expression here is the same as this expression here. Okay, now so n1 minus n2, I1 minus I2 is the same as n1 minus 0 all over I1 minus 0. Now the goal is to try and make IRR the subject. That's just all we want to do. So starting from the beginning, all you can do first is to cross multiply. Okay, that's what we did. And you cross multiply, and then you factor out what the terms will be. So if you have this one, see this, all this multiplying these, and then all these multiplying that here. Okay, so you just expand. You have N1, I1, N1, IR, and N2, N1, I1, and then N2, IR. That's what we have here. And it would be equal to expanding this N1, I1, N1, I2, and that's what we have here. Okay, so here we can group all the N's in here, okay? And N2, N1, we have it, take out all the I's on the other side, okay, and group the like terms. So now the idea is to make IR stand on its own. So you divide both sides by N2 minus N1 over N2 I1, N1 I2. And so you have this expression here. Okay. So well, here, so N2 I1 minus N1 I2 over N2 minus N1 is the same as the same. So all we are saying is so then there's no point. So even if we started from the logic, the basic logic of y2 minus y1 over x2 minus x1, or we use y1 minus y2 over x2 minus x1, either ways we should still be able to consider it as correct. Okay, so the assumption is that either of the expressions we still don't mind, because if we did y2 minus y1 first, then here you would have at n1 I2, okay, then the reverse. So it's just the same thing here. Now it says the accuracy of the IR is high when n1 and n2 is a positive and the other is negative. Yes, so this is normally the case when you have, for instance, if you have a graph, okay, that looks like this. Okay. Oh boy. If you have a graph, it's in the Cartesian plane, and you have, let's say, one of the NPVs here, maybe NPV2 is here, and NPV1 is here, it's a point with certain I here, and this one has certain I here. So, you kind of like have one point here, and then the other one here. So you see, when we have, so once you trace these 2 points, the point where it cuts it, that is the point where you have your IRR. Okay, so normally, preferably, if you have negative and positive, but it doesn't really matter. You can also extrapolate, so you can always have stuff. So let's try and solve a more realistic example, and then see. So the same information we have here. So you notice that here. Let me just draw your attention to something. You could be given this question. So just like I am saying for the IA, you could be given a question here, this question here, and you could be asked to find the payback period using, you could be trying to make a decision on the project, 1, using the payback period, 2, using the NPV, 3, using the annual work, 4, and using the internal rate of return. All 4 you could find here. If they are regular cash flows, if it's a regular one, just a simple question on regular cash flow, you could find an NPV, you could find the payback period, you could find the annual worth, you could also find, okay, so just, see things. So life is super easy. All right, so before we start, we pick 2 arbitrary interest rates, but to be on the safer side, because you guys are students and we cannot easily just ask you to just pick arbitrary. However, the understanding is even that whatever interest rate you pick with the IRRs will still be the same anyway. But all right, so we pick 2 interest rates. Let's assume interest rate at 10 and interest rate at 5. Sorry, 10 and 20. So for project one, we would find the NPV at an interest rate of 10. Okay. And then, so here, when the interest rate is 10%, this is what we have. Then for the same project one, we pick an arbitrary interest rate, let's say 20%, okay? And we find another NPV and we find this, okay? So this is the interest rate at the first interest rate at 1, okay? And then the second interest rate at 2. So interest rate 1 equals 10%, and then interest rate 2 is 20%. But at 1, the NPV is this, and then at 2, NPV is 4853. So we substitute it into the expression which says N1, okay, what's it called? NPV 1, okay, multiplied by the interest rate 2, okay, minus NPV 2 multiplied by the interest rate 1 divided by the difference between the interest rates. And so we have divided by NPV 1 minus NPV 2, okay? And when we solve it, we have 0.244, which is the same as 24.4. So 24.4 is the internal rate of return for project one. It means at this interest rate, okay, when you calculate, if you want to confirm, take this interest rate 24.4, okay, and use it to discount project one. You would see that by the time you are done and you subtract the discounted values and then from 50,000, you will end up having 0. Okay, so that's the. So we've done this for project one. We'll have to go ahead and do for project two. So again, we use the original interest rate from the question is 10%. Okay, the original interest rate for the question is 10%. So you get to pick an arbitrary interest rate. So we pick the interest rates 20%. The second interest rate is 10%. So at 10%, we find, sorry. So for project two, at 10%, we find the NPV to be this. Then at 20%, we find the NPV to be this. Okay. So we now have interest rate 1, okay, with an NPV of this, and interest rate 2 with an NPV of this. Okay. And so again, we go ahead and do our stuff here, and we say the NPV 1 multiplied by the interest rate 2 minus the NPV 2 multiplied by interest rate 1 divided by the differences between the what's it called, the stuff. Okay, so we'd have I think NPV1 minus NPV2. Okay, and here we had 2.47, and so this is 24.7. I think the first one was what, 24.4. So the first one was 24.4 and the second one was 24.7. Now, the question didn't give us any, what's it called? It didn't give us any information on an MARR, okay? It didn't give us its minimum acceptable rate of return. So here we will just go straight forward and compare the two. So in this case, we would select the IRR of 24.7. So we would rather invest in project two, okay, because it has the higher internal rate of return. Are we okay? My friends and enemies, are we okay?
Yes, please.
Yes, sir.
Wow, you guys are awesome. Okay, thank you for understanding everything. All right, so we can also have we done this? Have we done this? Yes, you can also find the NPV for a uniform cash flow as well, okay? You know, all these questions, all these things, they cut across. That's why I said I wanted to teach this one before I teach anything about. You notice that the stuff just follows suit. You remember we said that, well, if you're finding the present value for a certain annuity, okay, for an infinite cash flow, okay, so you have, let's say you have zero and, you know, okay, so 1, 2, 3, 4, it goes to a certain infinite period. We don't know, listen, and we can assume that, and normally we assume that when n is greater than 100 years, then it becomes an infinite, what's it called? Infinite flow, okay? So in the case of an infinite flow, if you want to find P, the present value for P, you know, here we can compute, we don't know what n would be. So all this expression in here becomes completely useless because n is an integral part of this expression. So when n is infinite, or when n becomes so large, these values here become so difficult to deal with, kind of like very difficult. Now you now start having something to the exponent, 2 to the e 0 point, some weird numbers on your calculator, and it makes life very horrible. So oftentimes when n we consider it as an infinite period, then the present value is just the annuity divided by the interest rate, okay? So look at it from this one. So when you have anything infinite and you want to find the present value, please think about it in this light, that A equals that. Please, this is different from the case of finding the, how do you call it, the payback period where we do CO over A, okay? So this is cash flows for perpetuity. Okay, when we say it is perpetual, it is forever, we don't know when. It's like saying that, let's take Akosombo Dam. I don't know if we would ever have a plan to break down Akosombo Dam and probably stop using it and maybe start using solar or wind or some other renewable energy source rather than the very expensive thermal energy. So suppose that we are supposed to be maybe making some investments into Akosombo Dam at a certain to maintain the stuff. So maybe we have, the government has just earmarked that, okay, so every year we will put 200,000 Ghana cedi in a fund, okay, at an interest of say 5%, okay, every year at an interest of 5%. For how long? We don't know. Till we'll review it at some point, or maybe, but 200,000 forever for Akosombo Dam. So in this instance, normally you don't know what n would be, so it will be difficult to compute the present value of this. So we say that the present value for stuff like this is just that periodic amount that comes in divided by the interest rate. It will give us a fair estimate of what our future value will be. When we have any type of cash flow that seems like we would be receiving or making, maybe we have certain inflow outflow that seems like it is going to be forever. We just compute the present value with this expression A over I. And I was saying that it is different from when we did the payback period, which is C over A. It confuses students a lot. I don't know why, but in most of the time, a little observation I have made is when you ask them for cash flow for perpetuity, then people do C over A. Okay, and then they I don't know how they find their values or whatever, but that uniform flow you give them is exactly what they use for the CO, and I don't know what they're thinking. But I know it happens under exams pressure. So we're saying if you have any infinite cash flow, so we give an example like the construction of a hydroelectric dam will take 12 years. It will cost 8 years 8 million in each of those years. The net revenue from selling electricity is expected to be 8 million per year, starting in year 13 and continuing at the same amount in perpetuity. Calculate the maximum rate of return needed to recover the project's investment. That's IRR. The NPV for I is 3%. Wow. So this is interesting, isn't it? Let's try and dig into this question. So first, the one thing I want you to do first is try and generate the cash flow diagram for this. Okay, when you're able to get the cash flow diagram, you would see how things. So it's like saying, it says that if we want to construct a dam, and then the first 12 years, so 1, 2, 3, 4, 5, so year 12, okay? And in year 13, we will go all the way 13, 14, 15, 16, 17, 18. Okay, so Akosombo Dam has been generating power for us and has been making revenue for the government. We don't know when Akosombo Dam will stop generating revenue for the government. Okay, so this is like a typical example. So here we're saying that we want to build a dam. And so we would, for the first 12 years, it will cost us 8 million. So, 8 million, 8 million, 8. Okay, all this is 8 million. Okay. Then net revenue from selling the truth is expected to be 8 million starting from year 13 and continuing perpetuity. So here, 8 million, 8, 8, 8. Oh, this one is 2. So this is also 8 million. So if we want to find the IRR, I think you can do it, isn't it? Someone should give me, looking at the cash flow diagram I presented, can someone give me first how we would find the NPV, what the NPV would look like? Anyone can help us with the concept of. Now, please, guys, I also encourage that you send your student number and your name, okay, for attendance purposes. I notice you guys don't write it. Well, if there's any mark for attendance, I just use my VLOOKUP. I check those numbers and names that are consistent, at least for 70% of the class time. You can give them 5%. All right, guys, so please, can anyone help us with a concept of how we will gain the present value? Course rep, are you here? Course rep for group 4. All right, so no one is interested. So here, we can first start from the costs and use our uniform cash flow procedure, which we know to be P equals A over I 1 plus I to the power n minus 1 all over 1 plus I to the power n. Okay, so this gives us our present value for the costs. So here n will be 12 years because it starts from 1 to 12. Okay, so and because period 0 immediately precedes the beginning of the cash flows, this will take us to period 0. Okay. However, in the other instance, this is perpetuity, right? Because it says it's going to for forever. So here we will take A over I. So this is going to be 8 million over our interest rate of 0.03. Okay, so we type, please don't use 8, use 8 million, okay, and do 8 million over 3 over 0.03, and it will give you a certain sum. But because this is a cost, we are interested in the net present value. Okay, so it will have to be the difference between the costs and then the revenue. Okay, so this aspect here is the inflow, and this aspect here is the outflow. So find the difference between the inflow and the outflow. That will give you your net present value. Okay, so that will be our net present value at 1. Okay, given the interest rate 1, which is 3%. Then you pick an arbitrary interest rate again. So let's say maybe NPV 2, we will compute it given maybe interest rate second I maybe at 7, okay, or 10, anything. Yeah, just pick an arbitrary interest rate. It should still be the same. The theory is sound. Okay, so we pick an arbitrary interest rate again, and then we solve for the second NPV given this interest rate for the 2 and find your stuff. And so then you can compute the internal rate of return. Please, is it sound? Do you understand what I just did?
Yes, sir.
Thank you. All right, so this is the idea here. So for NPV to be, for IRR, NPV must be equal to 0. So NPV is essentially revenue minus cost. So our NPV would be the revenue minus the cost. So the cost element would be to discount all these 8 million, okay, and bring it to period 0. Okay, and because it's a uniform flow, we use this expression, okay, and take it to stuff here. Okay, so well, okay, so the revenue PR here. Oh, so okay, so we apply the different approach. Not all this yet. Okay, so well, what I thought is one first approach. Maybe that's a longer approach to it. So, well, let's start again, and I can walk it over with you. So for the NPV for I, so it says the maximum rate of return needed to recover the project's investment, i.e. the internal rate of return. Okay, so here, what the question is asking us to do is, well, we should rather find the I, okay, that we would need to find what's it called, our internal rate of return. Okay. However, the argument here relies on the fact that for perpetuity, in the case of the perpetuity, we do not know what I is, but we know what A is. Okay, and so we are kind of like, the assumption in it is to say that we assume that our interest rate or the internal rate of return should be that interest rate at which our NPV would be equal to 0. Okay, so for the case of perpetuity, you're kind of like saying 8 over I, which we do not know, okay? And we do not know this, so we assume that we just kind of like leave this here. And well, they say this value in year 12 should be taken to the start of the project at period 0. So we take P, which is the present value, okay, as at for the revenue would be at year 0 will be 8 over I times 1 over 1 plus I to the power 12. In the sense that here, because this starts from period 13, right? So when we discount this A over I, it brings us to period 12, and you take it from period 12 as a single value to period 0, okay? So this is the example here to give us the present value for the revenues, okay? So this is quite understandable. Then when we come to the second instance, we again also need to, for the cost elements, we would, because it's a uniform flow, we have A over I, 1 plus I to the power n minus 1, all over 1 plus I to the power n here. So it's like you're doing revenue minus cost. So this whole expression here expresses the revenue aspect, and this whole expression here expresses the cost aspect. So the revenue part minus the cost part must be equal to 0. Okay, so it's like this expression here, that expression here equals this. So from the start, all we ought to do from the beginning is we can even use just this expression alone to find our IRR, and whatever I becomes, it could also be applied to this one. Okay, so it's like saying, so we can kind of like take, do we have we taught effective interest rates? Why did I solve this like this? I haven't taught you guys anything on effective interest rates. So, all right, so let's try and see how this works out. We cannot say, so let's group like terms and see if we can. Guys, hold on just a moment. Okay, so the basic approach would rather be to, let's do what we have been doing all this while. We take our I to be the interest rate at I. So we can solve for I for the cost part. So let's say 1, 2, 3, 4, 5, 6, 7, 8, or 8 million. And then from period 13, all this to a certain infinite period. So for this side, we'll use our A over I, okay? 1 plus I to the power n minus 1 all over 1 plus I to the power n, okay, to solve for the cost aspect. And then for the revenue, we'll have A over I. Now, when we have A over I for this, we will do our revenue minus cost. So whatever you get, take first interest rate as 0.3%. So you can have 8 million, okay, over 0.03. This will give us the value for the revenue aspect. And then you also apply 0.03 here to give you the cost aspect. You find the difference, you would have gotten NPV 1 at interest rate 1, which is 0.03. Then you pick an arbitrary interest rate again. Let's say, like I was trying to put across, let's say we pick an arbitrary interest rate of say 7 or 10, let's say 10%. Now you substitute again this 10% into this expression. So you again do for the revenue 8 million over 0.10, okay, in this case. And then you also apply the 10% here again. Then you're going to find the second NPV. So you're going to have NPV2, okay, whatever the value would be at the interest rate, this. So when you are done, you go do your expression, which is the second interest rate times the second NPV times the first interest rate minus the first interest rate times the second interest over N1 minus N2. Okay, and that would also give you your internal rate of return. Okay, so we'll hold on for this expression here. Okay, then you would get to understand how we got this one here. Okay, please, any questions yet at the moment? So you should find something approximately 5.94 along this as the internal rate of return. Okay. I see any question yet, or we go over again?
Please go over again.
Okay,
Go
so
over.
all right. Just a moment. Then get calculators and let's try and see whether it will give us the same solution. Okay. All right. So we have this expression here. We know that let's put the cash flow diagram. Okay. So let's say this is up to period 12, and this is from 13 all the way to infinity. Okay. So this starts from period 1. So from this point to this point, we'll be incurring a cost of 8 million. And then from this point to this point as well, we'll be incurring a cost of 8 million, okay? But this is to perpetuity and this is to the 12. So here, the two things. We first have to find, if we have to find the net present value, the net present value is always the inflow minus the outflow. Okay, so let's consider revenue. So revenue minus our cost, okay? So here, this is a cost because it was they were outflows of 8 million. So uniform cash flow starting from period 1 to period 12, we would have 8 million, okay, over, it says take 0.03 as the interest rate, and you have 1 plus 0.03 to the power 12 minus 1 all over 1 plus 0.03 to the power 12, okay? Now, this would give us the interest, the present value for the costs. Now, if we find for the revenue, because it's to perpetuity, we just say the present value would be A over I, which is the 8 million divided by 0.03. But please remember that this is from period 13. Okay, so when we apply this expression, it will bring us to period 12. So when you are done, take whatever we have from whatever this expression would be. Okay, so let's call all of this X. Okay, so let's say all of this is equal to X. Take X, okay, and discount it. So it will bring us to period 12. So take it and discount it 12 years to the one, and that is a single value. So 0.03 to the power 12. So whatever you have, okay, whatever you have from this expression becomes our present value for the revenue. Okay, so the present value for the revenue aspect. So when you are done, let's assume this is Y, and then the present value for the revenue is, let's say X1. So because I don't have a calculator here, so the net present value, or the first net present value would be equal to the revenue, what we are getting from the revenue, which is the X answer or the X1, minus Y, which is from the cost. So whatever we have, this is NPV 1, okay, and then the interest rate 1, okay, interest rate 1 will be 3%, okay. Then we would have to go over this procedure again with a certain arbitrary interest rate. So we pick an arbitrary interest rate again. So let's say 7%, 10%, any interest rate you want to pick. But just pick one other thing I should add. Try and pick, don't pick overly graciously. Just be a little controlled, because we say you can pick an arbitrary interest rate, you cannot go and pick 1,000% or 2,000% interest rate or something. So just pick something sizable. So 3%, you can pick 10%, 15%, 20%, whatever interest you want, but just let it be a little sensible. So now you can pick your second interest rate. Let's say we pick 10%. Then you use this 10% and go through this procedure again. So first, now at 10%, you solve for the cost, which is the 8 million. And then at the same 10%, you put it in for the revenue. First do A over I, and that single value, take that single value again at the 10% and take it over 12 periods and bring it to period 0. Now, you would have found the second NPV, okay, at this interest rate. So now you can now take this and go and apply the internal rate of return expression, okay, which says, let me be sure about it before I put the wrong. So it says that, okay, N2 I1. Okay, so here you're taking the second NPV, okay, multiplied by the first interest rate. So NPV2 minus the first interest rate, minus, now take NPV1, multiply it by the second interest rate, and take the difference between the second interest rate and then the first, sorry, the second NPV, and then the second NPV, and then the first NPV. What it gives you should be your internal rate of return. Is are we okay? Hello?
Yes, sir.
Yes, sir. Yes, sir.
All right, sure. Okay then. All right, so without wasting much time, we can get to the next session, isn't it? So let me post it. Okay, guys, so this is section 9. So we take a step back from section 10. So I only skipped, like I said before, I only skipped section 9 because I wanted to ensure some continuity. Okay, so today we will look at the case of amortization and sinking fund. And in that sense, we want to understand what amortization is and what sinking fund is. Then we will learn to build an amortization schedule and then a sinking fund schedule. So then we will talk about this, what a nominal interest rate is and what an effective interest rate is. Actually, what we say, a true interest rate and then a stated interest rate, or the contract rate and then what the true interest rate is. So this is the concept I was talking about. And then we will try and understand how we compute the effective interest rate and then the nominal interest rates. We would look at the continuous compounding in the, when interest rate is compounded continuously, and it just keeps going. Maybe it's interest is compounded daily or by minutes or by seconds. It's those typical kind of examples. For inflation and adjusted interest rates, I'm not sure. What, let's see, maybe we'll do it. Just to have, we may probably talk about it for you to have an idea of what inflation adjusted interest rates are. All right, so what is an amortization annuity? Okay, so the basic idea of amortization annuity is considered as, for let's say, for a layman's perspective, amortization happens to be that situation, a process or a procedure of repaying a certain borrowed sum. This is what is up. If you go to the banks, this is how they compute whatever loan that you take from the bank. The point is, you may not, if you were working with the bank, you wouldn't be doing it manually, like we are going to be doing soon, because there are computer systems. So even this could be done in Excel, or you could automate your Excel sheets that once you enter the value, Excel automatically generates all other components for you. So you don't, but what we are doing here is for you to understand the concept or the reasoning behind how loan payments or repayments are computed. Okay, so we say that amortization annuity is one way of repaying money borrowed over a certain period of time. Now, each payment accounts for both repayment of capital and interest. Okay, so each payment will be accounting for a certain part of the capital and then a certain part of the interest, and that's the idea. So normally when you take a loan and then an interest component is charged on the loan, every payment you make towards the loan, the idea is that they calculate the interest that has accrued on your loan, deduct it from that payment, and what is left goes against the repayment of the principal. Okay, so let's say that you have a loan of, say, 10,000 cedis. Okay, you have borrowed 10,000 cedis. And let's say at the end of the period, you pay 1,000 cedis, but the interest is 10%. What I'm trying to put across is here, your 1,000 cedis you're paying doesn't go against this 10,000 immediately, such that you will say, I have paid, 10,000 cedis. So I am left with 9,000 cedis. In the concept of the idea of amortization, the first thing that happens is this 1,000 cedis you're going to be paying every month. The 10% is first calculated from this 1,000 cedis. So here we calculate 10% on the 1,000 cedis, and that is 100 cedis. So in actual sense, only 900 cedis goes towards the principal that you have taken as loan, and 100 cedis is taken out as the interest. So that's how the idea of amortized loans or payments are done. So the debt is said to be amortized if this payment method is adopted. Okay, so banks and mortgage firms actually use this very popular method to to compute whatever computations that they need to do on your loan. Now, so it says that since amortization annuity assumes equal payments for each period, the present value of the equal payment amount can be determined using the expression that we have always known. Okay, so if you have a certain sum, you have taken a certain sum today, and you are supposed to be making a certain fixed deposit into the account over a period, we can go ahead and find that annuity that you ought to pay, given the interest rate and how long you have to pay the loan. And then you would pay that annuity towards the loan, and then given the interest rate that has been charged or stated on your stuff, then you can pay off your loan within the time period that you have. So let's understand what an amortization schedule is. The amortization schedule is more like a tabular representation of the computations that go into the repayment of the loan or a certain capital taken from a borrower. Okay, so, or let's say, sorry, a lender anyway. The borrower is the one taking the money, the lender is the one giving the money. Now, so an amortization schedule is a period-to-period specification of the debt left to be paid. For each period, it shows the amount of debt outstanding at the beginning of the period, the interest paid on the outstanding debt, the annual repayment, the amount of the principal repaid, and then the outstanding debt. Okay, so the amount of the principal repaid equals the annual payment minus the interest paid on the outstanding debt. Now, again, if some of you who do accounting anyone here who does accounting, do we have accounting students among us?
Yes.
Yes, okay, so, all right. So, can someone help us understand what you guys in accounting call the straight line method and then the reducing balance method in loan repayment? Is there anyone who has come across that concept in accounting before?
Yes.
All right, so please could you help us understand what these two methods actually are?
So
I can explain the straight line method.
Yes, my friend, go ahead.
Hello.
All right, so the lady who started speaking, please go ahead.
Hello.
Yes, go ahead, please. We can hear you.
Hello, sir.
Yes, we can hear you. Go ahead, give us the answer. Okay, so there was this first lady who had started talking.
Yes.
Give us
Say
your answer. Yes, go ahead. Yes, please go ahead.
the straight line method. When you are given the percentage, you have to calculate it on the amount given. So maybe if we are given 1,000, and maybe we have to calculate 10% on the 1,000, you calculate it, the 10%, and then you use the 100 with the straight line method. But as for the reducing balance, when you calculate the 10% on the 1,000 and you get the 100, you have to subtract the 100 from the 1,000. And then you use the 900 that you get as your new income. Then maybe in the next year, when you are given to calculate maybe 10% on that same you calculate it on the 900, and then the amount that you get, the 90, you also subtract it from the you add the 90 to the first 100 that you got. So when you get to 190, then you subtract it from the 900 that you have in the current amount. So the amount that you get, that's what you use for the reducing balance.
Okay, all right. Thank you so much. So for the straight line method, what she's telling us is that the interest is calculated on the principal for all the periods. So your interest remains the same, even though your loan balance is reducing or your outstanding debt is reducing. Okay, so if you probably take a loan of say 1,000 cedis, like you're saying, you have an interest of 10% to pay. Yes, we'll calculate that you pay maybe a certain sum. They will calculate the interest of maybe every month. So we have a loan of 10,000. Sorry, you pay 1,000 every month. Interest rate is calculated on the initial sum. Okay, so here you have 1,000. So we first start. The interest is calculated on this. So let's assume 10% will be too much. Yeah, but these banks, they don't care. So you have 10,000. Interest rate is 10%. The interest rate is calculated here, which is 1,000. Okay, then we move to the next period. But the next period, you probably have, if we deduct this 1,000 from this, you should probably have 9,000. But the next time, your interest again is still calculated on the 10,000. Okay, rather than calculating the interest on the 9,000, the interest still goes back to the 10,000 for all the periods. But for the reducing balance method, your interest is calculated on the loan, the balance at the end or at the beginning of a certain period. Okay, so as the balance reduces, your interest rate reduces. But for the straight line method, your interest rate remains the same even when your balance is reducing. Okay, so let's look at this question. Use this question and draw or generate, let's say, an amortization shadow. I don't know if we'll use this question too. All right, so we'll use a different question to do this. But for instance, say Kojo has gone for a loan of 100,000 to start a new business. The loan, excuse me, the loan is to be paid in equal installments over 10 years at an annual interest rate of 25%. What is the amount Kojo must pay the bank each year in order to pay down the loan fully at the end of the years, at the end of 10 years? So today, Kojo has gone for a loan of 10,000 cedis. Okay, 10,000 cedis. And Kojo, sorry, 100,000, forgive me, 100,000. Kojo is supposed to pay back this loan for 10 years. And then the interest rate is 25% for 10 years. Now, the question is asking us, what amount must Kojo pay the bank each year in order to pay back the loan? So what this is just asking us is like the annuity. So we know the expression A over I, 1 plus I to the power n minus 1 all over 1 plus I to the power n gives us the present value. But now we know the amount Kojo has taken. That's 100,000. We know the interest rate. We know that. What we don't know is A. So how much Kojo must pay to the bank every year is what we call the annuity, that fixed sum that Kojo must pay. And this forms the basis of every amortization, what's it called? It's like the basis, the crust of the amortization concept, because this is what the interest and all those things would be deducted from. All right. So we need to find that yearly amount. And remember this expression, we said P times I, 1 plus I to the power n, all over 1 plus I to the power n minus 1, okay? And this would give us A, okay? So we know that here, P is 100,000, I is 25, which is 0.25. 1 plus I to the power n is 1 plus 0.25 to the power 10, and then 1.25 to the power 10 minus 1. We put all this, you do all this computation, and then we find 28,007.26. So we're saying that at an interest rate of 25% for 10 years, Kojo will be paying 28,007.26 yearly to pay back the loan in full in 10 years. Are we okay? All right. So now let's take an example and build an amortization schedule with it. So from this point going, I would want your rapt attention as well. You don't like anything distract you. Now, it says most investors are always interested in the periodic cash flows and how loans are paid off. All savings accrue over time. An amortization schedule is meant to do just that. So let's say a debt of 10,000, okay, with an interest of 5% per year is amortized by equal annual payments over the next 6 years. Find the value of each payment and construct an amortization schedule for the loan. Okay, construct an amortization schedule for the loan. So today we have a loan of 10,000 and N is 6, the number of years, I is 5%. So we can find A, which we substitute into this expression, and then our A, which is the annual payment, the periodic payment, which we also call the annuity. Okay, the annuity here is 1,970.17. So this is our annuity. It means that for this loan of 10,000 for the next 6 years, we are going to be paying 1,970 every year towards the loan. Okay, towards the loan for 6 years. All right, so let's show this. Let's see how this amount, when we pay it every year at this interest rate for 6 years, would end up paying back this loan. So one thing I also need you to understand is in your amortization schedule, at the end of period 6, the balance should be 0 or should be approximately 0. Okay, so maybe you can sometimes, because we approximate some of the values, you end up having some 0.01 or 0.0. But if you have anything 1 point something, you're not done paying. And I can assure you, these banks, even if you have 1 + 1 left, they'll take it from you. So we slow down on our, what's it called, approximations in this sense. Now, there are some columns that we need. So I am going to be deliberately slow on this. There are certain columns that we need, okay, when we are developing our amortization schedule. Okay, so in developing our amortization schedule, the first column is our period. Okay, so the periods that we have. Okay, so we have from 1 to 6, but always know that today is part of it. Okay, however, you can just start from 1, because if the money is being paid at the end of the period, like I always told you before, that if the question doesn't specify when payment is supposed to be made, always assume the end of the period. Okay, of the period as the payment, payment time. Okay, so yeah, so we use these ones to probably indicate some of the formulas and everything. So then, after you've indicated a column for the period, indicate the beginning amount, a column for the beginning amount. So at the beginning of every period, what is the amount we have at the beginning of every period? What is the amount we have at the beginning of every period? Then the next thing is the interest paid at the end of each period. So we should have a column for the interest paid at the end of every period. Then we also have a column for the annual payments, the annuity that we have found, the amount that we are going to be paying at the end of every year. We call it the annual payment. Then we would also have the principal repaid. So how much of the loan have we paid? Okay, or how much is actually going against the loan? How much are we paying against our loan? That is the principal repaid, the amount that will be going towards paying the principal. And then the last one would be the debt at the end, or what we call the outstanding debt. Please don't worry too much about this A, B, C, D here. We actually used it to generate some formulas for you. So in case you want to revise, you can easily just see what we did for each column, okay? So the beginning amount, we call it A. The interest paid, we call it column B. The annual payment, we call it column C. The principal repaid, we call it D, and then the outstanding debt, we'll call it E. Okay? Please, are we following? Perfect. So let's start with understanding how we build up this stuff. So you have received a certain loan today. So today is 0, so we could put 10,000 here. Actually, nothing happens today. That's why we didn't even bother to put everything here. So if today we have received the loan at the end of year 1, okay, your loan is still 10,000 cedis. Okay, so at the end of period 1, remember when we did the cash flow diagram, okay, and we segregated these 0, 1, 2. This is the beginning, so this is period 1. This is the beginning of period 1. This is the end of period 1. Okay, however, this is the beginning of period 2, and this is the end of period 2. So you still have that concept in mind. So if I'm at 1, this is the end of period 1. So we've moved from this point to this point. Okay. So at the end of period 1, my loan is still 10,000. Now, the first thing I want to advise is after you have calculated your annuity from here, what we found here. Okay, some of you, sometimes things do happen and you end up having things jumbled up. So please, let me plead with you that once you have been able to calculate your annuity, when you come, just complete the whole period from 1 to whatever period you have, just fill it through. For the annuity, it is the same. Okay, the annual payment, it is the same over the time frame. So just complete it so that in case you mess up everything else, well, at least you won't get 0. Okay, you will have one column to be correct. All right, so at the end of period 1, our loan is still 10,000 cedis. Then we need to find the interest on the loan. So our interest is 5%. So this is like 0.05 times 10,000, or you do 5 over 100 times this. So the interest is 500. Our annual payment is the annuity we calculated as 1970.17. The principal repaid is how much are we going to pay against the loan? We have said that this is the annual payment. At the end of year 1, you have brought 1,970 towards your loan, but the bank is not going to take all this 1,970 against the loan. They would first deduct the interest from this amount, okay? And then whatever is left goes against the loan. So here we have 1970. So the principal repaid is the difference between the annual payment and the interest. So 1970.17 minus 500. And we have 1470.17. So in actual fact, although you are paying 1970 at the end of year 1 towards your loan, only 1470.17 goes against the loan. So your debt at the end of period 1 is going to be 10,000 minus what you're actually repaying, or what is being paid off, which is 1470.17. So at the end of year 1, your loan is left with 8529.83. 8529.83. So when we come to period 2, remember that period 2 here, okay, again, so let's show this here. 1, 2, in that order, 0, 1, 2. So you would agree with me that this is the beginning. So if this is period 1, this is the beginning of period 1, and this is the end of period 1. But believe me, this is the beginning of, this is also the beginning of period 2, and this will be the end of period 2. So this is the end of period 2. So if we come to 2, then what we had at the beginning of period 2, or this amount we have, which is at the end of period 1, is the same point the beginning of period 2. So at the end of period 2, the loan we have is this. What we have left of our loan is 8529.83. Then again, so this time around, because we are using the reducing balance method, which is the approach that the banks claim they use now. So they claim it's now the standard procedure, which is more fair than anything. So here we would have 5 again over 100 times the amount you have as your loan, or the remaining, the outstanding debt. So here our interest rate is now 426.5. So now you notice that the interest rate has reduced a little. So as your balance reduces, the interest rate also reduces. So then this is our annual payment. We will now find the difference between the annual payment and then the interest. And we have 1543.68. We deduct this. This is the amount that would be paid towards the loan. So we'll come 1543. Okay. We take it from what we have, what we are owing as at the end of period 2. And so we have 6986.15. So if this is the end of period 2, this is what we are owing. Also remember that this is the beginning of period 3 as well. So when we come here at the end of period 3, this is the loan we have to pay. So the interest is calculated on this amount, 6986.15, 349.3, 1970, which is again our annual payment. We deduct this interest from this annual payment. We have 1620.86. Then 1620.86 goes against the loan, and we have 53.65.29. So this is the end of period 3, at the same time, the beginning of period 4. So at the beginning of period 4, this is our loan amount. We calculate the interest on the loan amount. This is our annual payment. We find the difference between our annual payment and then the interest, and we have this. And then we take this value from what the loan is. We have 363 point stuff. Then we come here. At the end of year 5, we have this amount left. Our interest rate is calculated on 366.338. We have 183.17. This is our annual payment, which is just fixed. So we find the difference between our annual payment and then, or we take the interest from our annual payment, and this is what we have. This is what we have. Then we take this amount from what we actually owing as at that period. So we have 1876.38. Then, so this is the end of period 5, and at the same time, the beginning of period 6. So we come to period 6 with this amount. We calculate the interest on what we are left. It comes 93.82. We have, this is our annual payments fixed. So we find the difference between the annual payment and then the interest rate. So we have 1876.35. So the difference, we take this and subtract it from what we were owing. So this is like, this is, you're gonna have, what we were owing was 1876.38 minus 1876.35. Okay. And so I think this is as a result of some the approximations we did. So this is like 0.03, and we assume it's 0. So at the end of the 6th year, we should have exhausted our loan amount. Okay. So given that we have paid, we started with 10,000. At the end of the 6th year, we have finished paying off 10,000. Please, any question?
Yes, Doc.
Please go ahead.
Doc, please, this one, is it the reducing balance method? Since we are taking the interest from the annuity to get a capital repaid, the principal repaid, is this the reducing balance method or the straight?
This is the reducing balance method. That is, you see, if it were the straight line method, right? The interest would constantly be calculated on the 10,000. Okay, the interest will not be calculated on the new balances we have at the end of the period. Is that okay? In that case, like the interest will remain fixed. It will be 500 throughout. Okay, but for the reducing balance method, as your balance reduces, that's why it's called reducing balance. As your balance reduces, your interest rate, your interest amount also reduces. Is that okay? So look, we started with an interest of 500. It came to 426.5. It came to 349. And then in the last year, the interest we were paying was 93.82. Is that okay? But if it were the straight line, interest will be fixed. Interest will be calculated on this fixed sum every period. No, we don't care in that sense. So for the reducing balance method, the amount you pay towards the loan or the principal repaid would be increasing gradually. You notice that as the periods go by, your principal repaid is going up and then your interest is coming down. But if you were the straight line method, your interest is the same, will be fixed. And then your, your principal repaid would rather be going down. So it will take you a longer period to pay the loan, to pay for the loan. And then the bank will make a lot of money out of it. Is that okay?
Yes, sir. Well understood. Thank you.
All right, sure. Please, any other questions? So we move to the next concept. Please, what time are you supposed to end the class?
9:50.
9:50.
9:50.
Okay, so we have 1 hour left, isn't it?
No, 1 hour. Yeah.
Julius, I have not asked you for
Time
your
is
opinion.
up.
Julius, I have not asked for your opinion. Please just ask your question and put your hand down. I know from my watch we have 1 hour left. Okay.
Please, time is up.
Who is saying time is up? I mentioned your name and then your student number. Let me be very sure that you are the one saying time is up.
So we have 23 minutes left.
It's not time. All right, Julius, if you have a question, ask your friends.
Sorry, Adrian.
Okay, sorry. Thank you. Okay, thanks for reminding me that time is up. Okay. You see, the same way you don't want to give me, please just a moment. The same way you don't want to give me extra time. When you're also writing your exam, don't ask for extra time. Is that okay? Me too, when time is up, I'll also be telling you time is up. Sorry, time is
Please
up.
continue.
Sorry,
You continue. When we are okay, we will tell you.
No. I'm not going to do anything.
Sorry,
make you-
beg.
Come on, come on. It's nothing.
Beg.
Sorry. This one is only. Please, this is not to the whole class.
It's only
This is
for
to
Asari.
Asari. Yes, it's only for Asari.
Okay, thank you.
So the
sir.
exam,
Thank
I'll
you.
stand
So
by
even reduce
Asari's
it.
desk. Asari, the moment is time. Even 1 second, I will not allow you to write anything. I'll take your paper from you. So I'm also going to do the same. Exactly times up, I'll stop. All right, yes, Julius, you're going to ask a question. Please go ahead.
Okay, thank you, sir.
Yeah.
Please, my network. Is it always that the annual payment to be given the person? Or something?
You would calculate the annual payment.
You will find annuity.
Yes, exactly. Look, it's here. We founded the annuity. You're only giving the present value, the interest rate, and then the years. Okay. So so if you make a mistake, with the annuity, you notice that by the time you are at the end of the 6th period, you still have some. You still wouldn't be able to have paid the loan. Then that point, I am happy. It means that your annuity is wrong. You get it. So it means everything you have done is also wrong. So this one, this kind of question, when you look at it and you just mark it like this. You look at the paper and just, that's all, and you give 0. You see, that's just how you don't have to spend time into doing all this kind of stuff. Okay. On a good day, maybe when I'm happy on that day, I'll give you 1 for wasting your ink and writing all this will give. But on a regular day, you just have to strike it out and say 0. The guy has gotten everything wrong. That's why I told you that the annual payment here forms the basis of everything that we are doing here. So if you get it wrong, everything you're doing here is totally wrong. Okay. Yes. Any other question? All right. No question. Let's go ahead. At least let me do sinking fund. All right. So the next one we will refer to as the sinking fund. Now, the sinking fund is more or less a reverse of the amortization, whereas an amortization shadow typifies the repayment of a loan. The sinking fund depicts an investment of a certain sum. Okay, so in the case of the amortization, we have the present value. Okay, we have the money at present, and we are considering how we will end up paying it at the end of a certain future date. However, for sinking fund, we are looking at what a certain sum we have today will grow to become in the future. So think about it today. If you have, let's say, some of us love cars, okay? So maybe in the next 5 years, I want to ride a certain GLX, the newest model of the Benz GLX that would be available. Okay, and I go to Silver Star Towers and find out how much it is costing currently. And then I kind of like say, so given the rate of inflation, let's say currently the rate of inflation in Ghana is 10.6. And so maybe I double it. I want to be sure that things will not overturn me. So I double, let's say, make it, let's say 22%, just to be on the safer side, which actually is not the case, no, but 22%. So now, if I have a certain sum, maybe I have 1,000, I want to be putting down 1,000 cedis. Now, I have to find, I want to see what will happen for these 1,000 cedis to grow into a certain sum, okay? That would give me a certain amount that I can use to buy the GLX at some point. So maybe if the GLX is going to cost, let's say, so now I'm here and I walk up to a bank. So in the next 5 years, what will your interest rate be? Oh, we will give you an interest rate of, let's say, if in this fund, we are generous people, so we'll give you interest of 10%. Okay. Then I kind of go to Silver Star Towers and I'm like, okay, so the GLX in 5 years' time probably will be costing 350,000 Ghana cedi. In the next 5 years. So in 5 years, I want to ride in that Benz. Like by then you finished school, you started working, maybe you are planning on getting married at some point, and so you need to look some way. At least you want to enjoy life more. How much should I be putting down at this interest rate from now, so that by the end of the 5 years, I would have raised 350,000 Ghana cedi to buy my GLX. Even if I won't buy the GLX by then, I'll buy a land and start some project, or probably do something with my life with that money. Like sometimes I wonder if you're able to raise this amount of money, can you just walk into a showroom and buy a car with all this amount of money? Nah, it's difficult to make such a decision unless you have it so much in excess. Anyway, but some of you may be able to do it. So, but the aim is to grow the certain sum to a certain amount. So for the sinking fund, the accumulated future capital is what we call the sinking fund. It's like, so you see, you are just sinking your money. The money is just going into the sink, is going into the sink. One day when the sink is choked, you open it and you take out everything in the sink, and whatever is there is the total bulk of things stuck up in your sink. So the capital repayments made for each period are annuities. The sinking fund is an annuity invested in order to meet a future commitment. So the sinking funds are used for repayment of debts due in the future, not repayment of debts that you have taken in the present. Okay. Now, providing the sinking funds, for instance, providing sinking fund to purchase new assets in the future when existing assets are fully depreciated. Okay. So now, if you are to do a sinking fund, the fund would be, if it's for a debt, you have the standard amount, interest paid, equal amount prepaid. For the fund, you would need equal payment period, interest earned, and then amount in full. So let's look at trying to understand this concept here. Now, sometimes the beautiful thing about the sinking fund, it is the one that can be used to confuse students very well, and it's so easy to confuse students. This is the first question. Let's look at it. It says that A company borrowed 46,000 cedis, which is compounded at 15% per year, to finance a new production line. The debt will be discharged at the end of 5 years with regular annual payment into a sinking fund which pays 11.25 per year. Calculate the annual payment into the fund. Construct a sinking fund schedule, assuming that the first payment into the fund is made at the end of the first year. Now, guys, please, so let me also draw your attention to this. Suppose I have said that the first payment will be made at the beginning. So when you have period, okay, then you're going to have 0, 1, 2, 3, 4, okay? It's for how many years? 5 years, okay? So your first payment will be at period 0, okay? That is if it's at the beginning of the period, okay? Then this will also be another one. This will also be, so by the end of period 4, you'll finish paying. There will be nothing in period 5, okay? Because this is going to be 1, 2, 3, 4, 5. But because it says that the payment is made at the end of the period, we will start from 1. Please have these rubrics at the back of your minds when you're doing this. Now, guys, tell me, which of these interest rates are we going to use for the sinking fund? Anyone? Quick one.
11.25.
Okay, 11.25. Thank you. But trust me, in this question, there were students who still use 15%. I couldn't believe it. But there is something, this question looks very harmless, but it's a very harmful question, Please, let's analyze this question carefully. Since a company has borrowed 46,000, which is compounded at 15% per year to finance a production line, it means that they have borrowed the 46,000 now. So if you have to prepare your sinking fund, we say that the sinking fund is stored a certain amount in the future. So in this question, what threw a lot of the students away was the fact that they built their sinking fund against this 46,000. You see it. The sinking fund is towards a certain amount in the future. So what this is trying to tell you is that you must find the future value of this amount, 46,000, a single amount. So we know future value is P 1 plus I to the power N. Here, I is 15%, N is 5 years, P is 46,000. So whatever the future equivalent of 46%, 46,000 would be, that should be the one you use to find your needs. Then the next thing is here, because the sinking fund is for a future value, and you have to find the annuity, it means we are interested in F equals A over I, 1 plus I, okay, to the power N minus 1. This is the expression you should use to find A. So here, you're going to do a whole different stuff. You can make A the subject, okay? You can first multiply through by I and have F times I equals A times all this, and you divide everything by. So A is just going to be F times I divided by 1 plus I to the power N minus 1. Okay, that will give you A. Now, so let's get into it. So you see, the first thing to do is we must find the future equivalent. So please look out for these kind of stuff that will show you. Someone understand, and all of them understood. At least I was happy. It means that when I taught the sinking fund, they understood, but they did not understand the concept. A company borrowed 46,000. It means they have taken this amount, which is compounded at 15% per year, to finance a production line. The debt will be discharged at the end of 5 years with regular annual payments into a sinking fund that pays this. So calculate the annual payment in the sinking fund. So we have to first find the future equivalent. So the future equivalent of this is 92,522.43. Then, having found this amount, we would now find the annuity, that annual payment that we can use, okay, to offset. We can put in a fund and to offset this loan at the end of 5 years. So this is the future value. A, which we don't know. I is 11.25, okay? N is 5 years. So put this into this expression, and then we have 14,782, okay, as the annual payment. So every year, at an interest rate of 11.25, we should put 14,782.68 into that account, into our sinking fund. And then at the end of 5 years, we would have raised this money and paid off the loan. So let's see how the sinking fund works. The sinking fund is relatively easier compared to the amortization. So we have first column, the periods. Okay, we need the periods. The second thing is the total amount in the fund. So you can just have amount at the beginning period or amount at beginning. Okay, so amount at beginning. Then you have the interest paid at the end of the period. We need the interest that is paid at the end of the period. We need our annual payment. It is also here, the annual payment. And then the total we will have in our fund, the total in fund. So let's start. Payment was at the end of the period. So we can easily just start with. So at the beginning, we haven't made any investment into the fund, okay? And so there'll be no interest earned. But at the end of the period, we would deposit this amount in the fund. We'll deposit this amount in the fund. So payment is made at the end of the period. So think about it here. So it says, this is our time value of money. This is period 1, period 2, period 3 in that order. Okay, sorry, period 1, 2, 3. This is 0. We did not make any payments here at this point. We made the first payment here. Okay, so the first payment is here. So, and you remember, this is the end of period 1. Okay, this is the end of period 1, at the same time, beginning of period 2. So at the end of period 1, this is where we are making the payment. So we can't earn any interest. So you notice that there is no interest here at the end of period 1. So we have made our first payment. So the total in the fund at the end of period 1 is this. But bear in mind that this is the end of period 1 is also the beginning of period 2. So when we come here, at the end of period 2, so at the beginning of period 2, we have this amount in the bank. So this is the same thing here. The same, what we had at the end of period 1 would be the same we would have at the beginning of period 2. So at the beginning of period 2, we have this sum, but now a whole period has elapsed. So now at the end of period 2, okay, at the end of period 2, so again, just bear in mind here, this period here, which is 1, is the end of period 1 and then beginning of period 2. So if we are here, this is the end of period 2. Now at the end of period 2, now 1 whole year has passed. So our money must accrue interest. Okay, so now we will calculate the interest of what is in the fund, which is this amount. So we have 11.25 over 0 over 100 times that, so which is the same as here. You can just do 0.1125 times what we have in the account of 14,782 times. Anyway, it's the same thing. Right. So the interest that we have earned is 1,663.05. But bear in mind that at the end of period 2, we must also make another deposit. So think about it again. So this is 0, 1. We made our first deposit here. Okay. So this is from here to here is period 1. So now when we come here at period 2, this is the end of period 2. We must make a deposit. But because 1 period has elapsed, interest must be earned on this amount here that we deposited here. So now we must make our deposit for period 2, which is this one here we have made here. So the total we have, okay, at the end of period 2 is the new installment we have made plus the interest plus what we have at the beginning. So here we, oh boy, I shouldn't have done that. So this is 0, 1, 2, 3. This is our first installment. This is at the end of period 2, the second installment, but this one must now have interest because we have moved to the end of period 2. Now, how much do we have in total in our account? The initial installment we made here, okay? The interest, which is this one here, the interest that has accrued on it, okay? Plus now the new installment we have made us at the end of period 2. When we put all together, it will give us our balance at the end of period 2. So at the end of period 2, it is the first installment plus the interest that has accrued on it, plus the new installment at the end of period 2. And remember, the end of period 2 is the beginning of period 3. So when we get to period 3, so this is the beginning of period 3, we have this amount, we have this here at the beginning sum. Then we are moving to the end of period 3. So we are here. That is why we are this period. We must now calculate interest on what was in the account. So now we will now calculate interest on the 31228.41, and this is our interest. Then at the end of period 3 itself, we must again make another annual investment. So our total in the fund is going to be what we had at the beginning, or what was here at the beginning of period 2, plus the interest that was earned on it, plus the new or the additional annual payment we have added. So we put all three together, this plus that, and we have our sum here. So when we come to period 4, the end of period 4, this is the amount we have at the end of period 4, but there must be interest on the previous amount here, plus the new, what's it called, payment, the annual payment we must make. So we sum everything to this plus that, and it gives us this. Then in the 5th year, this is what we have. This is the beginning of the 5th year. The end of period 4 is the beginning of this thing. So we have here. At the end of period 5, we still have this amount. So interest will be calculated on this amount here, which is this. Then we must also make another deposit at the end of year 5, the last deposit. So we add this, plus that, and we have this, okay? So at the end of the period, we should have 92.552.46, okay? Which, because of our approximation, we've ended that we have overpaid. So we'll take our 3%. Yes, whatever it is. So you notice that we would have raised enough to offset the loan by the end of the 5th year. So the trick about the amortization, the sinking fund, is once you're able to get the value at the beginning, you calculate the interest on that value at the beginning, plus this, you sum everything on that line, and it gives you the total. You bring the total to the next period, calculate interest on that total, introduce your annual payment again, and sum everything, and it gives you this. Take this and bring it here, calculate interest on this, okay? And then the annual payment is still there. Sum everything, it will give you this in that order. Okay, so it's, again, I also advise that once you've been able to calculate your annual payment, once you write the columns, the period, the amount at the beginning, the interest rate at the end of the period, the annual payment, once you have annual payment, complete this column, fill in the annual payment so you don't have to forget anything. And then the total amount at the end of the period. That gives you stuff. So you notice that at the end of the period, your sinking fund, the value at the end of period 5 must be equal to this future value that you calculated. Okay. All right. Please, any question? Any question? Anyone? Any question?
Hello, Doc.
Yes, please. Go ahead.
This please, my so please, I didn't get the period 1. What are the 00? If you can take me through.
Okay, so period 1. So here, I need you. So you need to first understand. You need to visualize it from the cash flow diagram. Okay. So let's say. Oh, sorry. Okay, so let's start from here. So this is 0, right? This is period 1. So not period 1. This is time point 1, time point 2. Okay. Now, if we go back to the question, okay, the question says that the first payment into the fund is made at the end of the first year. Okay, at the end of the first year. Okay, so this is telling you that the payment is at the end of the period. Do you agree?
Yes, please.
All right, perfect. All right, so if it's at the end of the period, then it means that our first payment, now when we taught the cash flow diagram, you know, this from this point to this point is period 1. Okay. Oh boy. Sorry, just a moment. So this is period 1, isn't it? So this here, we'll call this period 1. Okay. So, but this point 0 is the beginning of period 1, and then 1 here is the end of period 1. So if our first payment is made at the end, okay, at the end of the first year or the first period, then this is where our first payment is going to be. Is that okay? So the assumption is that we don't have anything at the beginning of period 1. Do you get it? Because the first payment was made here. So at 0, there is nothing in the fund. I hope you get it. Now, if there is nothing in the fund today, then there is no interest as well. I hope you get the point. This, I hope you understand. Do you get it? Now, if there can be any interest,
Yes, dog.
our first payment
Yes,
was
dog.
so our first payment was made here. So we will only have the only thing we'll have is the payment here. First payment. So at the end of period 1, all we have in our account is the initial payment that we have used. Okay? All right. So at the end of period 1, all we have in our account is just the initial contribution. Now, we will move. Now, you agree with me that the end of period 1 is also the beginning of period 2. So we will now make another deposit at the end of period 2, which is here. So here at the end of period 1, we have this amount, but the end of period 1 is the same as the beginning of period 2. So we have this amount. At the end of period 2, which is here, which is at this point, okay, at the end of period 2, which is at this point, first, what we have in the amount would be what we deposited here, which is this amount. Okay, but now we have moved from period 1 all the way to the end of period 2. So it is one whole period has elapsed. So we need to calculate what? Our interest. Okay, there must be interest earned on what we deposited at the end of period 1. So here, you notice the interest is calculated on what we have here, what we deposited at the end of period 1. Okay, it's here. But again, now that we are at period 2, the end of period 2, we must make another deposit. We are going to be making the yearly deposits until 5 years. So here, we must make another deposit. So at the end of period 2 here, at the end of period 2 here, the second period, what we have in our fund would be the first deposit we made at the end of period 1. Then, because we moved from the end of period 1 to period 2, the first deposit had to earn some interest. So the interest that was earned on it is this one. This was what we had at the end of period 1. Then now at the end of period 2 itself, we must make some deposit again. So this is the deposit we have made at the end of period 2. So in total, at the end of period 2, we are going to have 3 items. The initial deposit we made at the end of period 1, the interest that came on it, and then that investment again, the annual payment we made again at the end of period. So we put all 3 together and we have this. Is that okay? So we are here. We have 3,122.8.4 at the end of period 2. Again, remember the end of period 2 is the beginning of period 3. So when we move to period 3, the end of period 3, one whole year has come. So this, what we have, we'll take this amount and bring it here. So this amount is what we have here. Okay? Then interest will be calculated on this amount. But because it's the end of period 3, we must make another deposit. So the total is going to be the new deposit we have made, plus the interest that was earned on what was already in the account, plus the principal that was in the account. We put all together and we have this. So you just repeat the same process till we get to the end that you found the future value. This are we okay?
Yes, Doc. Thank you.
Yes, sir.
All right, so please, any other question?